Hello, welcome to the screencast for chapter 8. So we're going to start talking about vectors. A lot of this is definitions, alright? So for instance, a vector is a quantity that has both magnitude, which is number, and direction. So magnitude means number and direction, okay? So examples include velocity. So if you are in physics, you know velocity, what it is. Alright, so velocity is literally how fast you're going in a certain direction, right? Has a magnitude, 60 miles per hour, and a direction, north. You can have a velocity going 60 miles an hour north because it has magnitude, the number, and direction, north. Force, right? Let's say you go push your friend on a swing, right? Your push, you could push with 200 newtons of force, right? Newtons is just your unit of measure. 200 newtons. 200 newtons is your magnitude. But which way are you where are you pushing them? Oh, forward. So it's a forward direction, backwards, north, south, left, right. The direction doesn't necessarily have to be degrees, but a lot of times we use degrees. So you push them with a force 60 degrees north of the horizontal. So you're really pushing them high on a swing. Okay. So a quantity that only has magnitude and no direction is called scalar. So if you step on a scale, it tells you a number, right? A scale only tells you a number. It's not telling you which direction, right? How many pounds you are, how many kilograms. It's just a number, right? A scalar is literally like a scale. It only tells you a number. For example, let's say the velocity of a certain object is 6 meters per second east, speed is meters per second, and your direction is east, right? The 6 meters per second is your magnitude. And its speed would simply be 6 meters per second. So the velocity, 6 meters per second east, speed, 6 meters per second. So speed is how fast your speedometer tells you. Velocity is with a direction. That's why I say vector is literally an arrow, right? Your vector is a number with a direction, with an arrow. So if we look, okay, is it scalar? A ball thrown northwest at 60 meters per second, so northwest is the direction. 60 meters per second is the magnitude. A tennis ball served 110 miles per hour. Well, I hope that's not served at me. It does not say the direction, so it's just a scalar. Versus a sprinter running 100 meters north. Okay, 100 meters, this is the magnitude. North is the direction. So this is definitely a vector quantity. So vectors are usually represented as an arrow diagram or a directed line segment. So look at the vector shown below. Just so you know, in physics, you will see it as a line over or this like half arrow looking thing. So A is the initial point. We call this the tail. Right, we call this the tail. This B, right, you see where the arrow is pointing? It's called the head. Or I'm going to call it the tip, right? We're going from A, where we're starting, to B, where we're ending, the terminal point. The vector is denoted, A to B, A, or vector A. So you see how there's like a half arrow above those, or a bolded letter. Okay, so tip to tail. So a vector in standard position is one where its initial point is at the origin. Awesome, so here you can see the end of our vector is at point A. The start of our vector is at point B. Right, and the scale is 1 centimeter is 5 feet per second. So if you go and you measure it, you'll see it's 2.6 centimeters long. Okay, so the direction is the angle, 35 degrees. The magnitude is the length of the segment. So that's just the absolute value. Here is 2.6 centimeters, so 5 times 2.6 is 13 feet per second. So the full vector would be 13 feet per second at an angle of 35 degrees. Bearing is another way to express direction, right? The direction of a vector is sometimes expressed as a bearing. A quadrant bearing is a directional measurement between 0 and 90, east or west of the north-south line. So notice this is different than the standard position. It is the angle between the vertical line and wherever your angle is going. So here we have a bearing that is going east. It's 35 degrees towards the east. If this was the vector going this way, right? If I had a vector 35 degrees that way, it would be west because you're going west of north. Okay? A true bearing is a directional measurement where the angle is measured clockwise from north. Okay, so remember north, south, and we're going clockwise, which goes this way. That's a true bearing. It's weird, but you have to start at north. So it's always giving us 3 digits, so direction 25 degrees clockwise from north is 0 to 5. All right, parallel vectors. So I believe you have an idea what this is already. Parallel vectors have the same slope, right? Maybe the same direction, maybe opposite. You see A and B and C. Let's see, E and F. These are all parallel vectors. They have the same slope. But notice the ones I highlighted in pink are going up to the top right. And then, let's see, E and F are going down. Alright, equivalent vectors. Ones that have the exact same length. So while A, B, and C are all going up to the right, A and C had the same length, so you just have to measure it. So this is equivalent vectors. A is the same vector as C. Opposite vectors, they have the same magnitude but opposite direction. So notice A and E or C and E, they're exactly opposite. So you see how E is equal to negative A? That means negative E is equal to A, right? When you add them, you'll get 0. Also, if you change this sign, one is going positive, the other is going negative. So taking negative of a negative makes it positive. Cool. Resultant vectors. Here, there's 2 ways to find a resultant vector when you add 2 vectors together. You can do the tip to tail method. All right, that's an easy way to draw it. But if you want a number, okay, you can use the parallelogram method. So you copy your A, copy your B, and then the resultant is just the vector that forms the diagonal. Find the resultant vector. Find the resultant of each pair of vectors using triangle or parallel method. Okay. Same magnitude to the nearest centimeter and direction relative to the horizontal. So I have V and I have W, and I'm trying to add V plus W. So notice that we draw our angle V, right? So I measured that this was 60 degrees from standard position. Okay, and then tip to tail. So the tip of V is where I'll start the tail of W to add it. And then once you draw all your vectors, right, then you draw your resultant from where you originally started to where you ended. So it doesn't matter if you're adding 2 vectors or 20, right? The resultant vector is always from where you started to where you end after you do the tip to tail method. Okay, so awesome. I guess that wasn't 60. The overall is 60. So what I did was I just copied this over. I drew it, and then I used a protractor to find the angle. Notice A and negative are opposite vectors. You add them, you get a vector of 0. And if we multiply a vector by a scalar, right? So 3, if we multiply vector A by 3, it's 3A, meaning 3 times the length. So this is the question that pops up in your ALEKS over and over again. So draw the vector diagram of 3x minus 3/4 y. So 3 times the length of x minus 3/4 the length of y. So I'm making x 3 times as big, I'm making y only 3/4 the original size. Okay, and I'm taking 3 minus that. Okay, so I draw my x. Here's my x. And then I must add, well, let's see, the y is originally going up. So since I'm flipping the direction at the negative, my y now goes down. And it's only 3/4 the length. And so my resultant vector already, so we draw my 3x vector, and then tip to tail, so I have to do the tail of my other vector, starting at the tip of the first one. Cool. So vector components. Vectors which add to create a vector R are called components of R. So if you have a triangle, or if you have a vector, you can break it up into its x and its y components. For physics, this is how you find 2D motion, because you break it up into horizontal and vertical. All right, when digging in his garden, whatever, you can change it to your name. You push a shovel into the ground with a force 630 newtons and angle 70% with the ground. Okay, so you're pushing a shovel into the ground, and the angles between you and the ground, and that's 70%. 70 degrees, I'm sorry. Draw a diagram showing the resolution of the force that you exert. Okay, so I just draw out the triangle, break it up into components. Think about how you could find the x, how you find the y. Oh, literally, SOHCAHTOA. Right, this is where chapter 4 comes into play heavily. Right, sine is the opposite side from 70 degrees. Cosine is the adjacent side. So, to solve for force in the y direction, right, sine is opposite that length over hypotenuse, which is 630. Multiply by 630 on both sides, you can get the force by itself. And that is the whole first lesson. If you have more questions, you guys can Google Khan Academy, help each other. I think it's great. Good luck.